Okay, hi, and I think it's time for us to start this webinar. Good evening and welcome to all of you. Today's webinar will be about the AWS certification, and in that, I'm going to talk to you about EC2 and EBS. Basically, I'm going to discuss about the important points of these services and what sort of questions you can expect from these services. The important thing to note is that I assume you already have knowledge about EC2 and EBS. So this is not a session where I'm going to teach you about EC2 or EBS. You should probably, look it up in the AWS or we have the courses in Cloud Shiksha and all that. You can have a look at that. And this is more to reinforce your learning and to give you an idea on how to tackle some of the questions that appear during the AWS certification exam. So let me share my screen with you and we will proceed from there on. I will show you a presentation where I'll be telling you about the important questions and how to handle them. And at the end of this, if you have any questions for me, I'll be happy to answer. Just hold on for a minute and we should be getting this through. Here you go. We have the AWS certification webinar for EC2 and EBS. As I told you earlier, this is the intent of the webinar. So the webinar series is not intended to explain each service to you. It is assumed that you know about the service. The webinar series will talk about the important points of each service. It will discuss the probable questions. And if you want to learn more about AWS, you want to get yourself certified and you need training, you can always visit the Cloud Shiksha Academy, which is at academy.cloudshiksha.com. So let us start with EC2. Now, EC2, as you all know, is Elastic Compute Cloud. And the important segments within EC2 are the AMI, the Amazon Machine Image, the instance type, the instance store, the Elastic Block Store, the key pair, the security group here. These are some of the important aspects of EC2. I'll be looking at some of them which appear many times in the exam. So let us talk about those. First is the AMI. First thing we need to remember about AMI is that AMI will belong to the region in which it is created. So you have an instance running in Oregon region or an instance running in North Virginia or Mumbai. When you create an AMI there using that instance, then the AMI is available only in that region. So if somebody says that, can I boot another system in a different region using the AMI? The answer is no. You can't directly access the AMI from another region. One way it can be done is that your AMI can be copied from one region to another. So this copy option is available. So if you want the same AMI in a different region, you go there and copy. Secondly, whenever the AMIs are created, it's generally private in the sense that only you can launch it. I mean, when you make the AMI, only you will be able to launch it. You can change the permissions of the AMI to make it public. If it is made public, then anyone else can launch their instances using your AMI. Or you can give permission to a particular account. So you can tell that a particular account can use your AMI, and then that account, whoever is the user there, will be able to access your AMI. Now, the AMIs that you get from Amazon, they can be EBS based or instance store based. Now, when AMI is EBS based, your root volume is an EBS volume. And when the AMI is instance store based, your root volume is an instance store volume. I hope you know what is an EBS and what's an instance store. Anyway, I'll be talking about that further down the line in the same presentation. Now, in the EBS backed volume, EBS backed AMI, you can stop the system, you can restart the system, and nothing would happen. It will come up as usual. But if you use an instance store based AMI, sometimes also called as S3 backed instance, now when you do that, when you shut down the system crashes, all the data which is on the instance store gets wiped off. So in the case of an instance store backed AMI, every time the AMI is taken from an S3 bucket and put onto your instance store. Therefore, the starting up of the instance would also be slower if you use an instance store based AMI. Most of you, if you are using the free tier and if you are using the T2 micro to do all your experimentation, may not have seen instance store AMI, because what AMIs we get for T2 micro, mostly EBS based AMI. So we use EBS based, but there are certain instances which have instance stores in them, and those instances can use instance store based AMIs. Next, the questions that appear many a time in the certification exam are based on performance. Now, it's well known that there are different instance types, and each one of the instance type provides a different performance. You know, some are compute optimized, some are memory optimized, some are storage optimized, some are graphic processor unit based, GPU based, and so on. So you don't need to really by heart every instance type and what's the configuration, but it's better to go through the instance types at least on a family basis and say, okay, this family means this. So which families are general purpose? Which families are memory optimized? Which families are compute optimized, and so on? Here we have to see about a couple of things. One, you have to see what is the network performance of an instance. In the exam, you would get a question which talks about networks. It talks about the speed not being enough and so on. Your immediate reaction would be to look for an answer which is about networking. You can say add one more ENI or add something else which is networking based. But the answer need not be necessarily a network based answer, but it could be an instance based answer. What I mean is, if they say that you're trying to transfer data, but there is some limitation and such things, then what happens at that time is that your instance which you are using is an instance which has a very low network performance. So if you see your basic instances, you will find that they tell you which have medium network performance, which has high network performance, which are 10 GB network performance, which are 25 GB network performance. So whenever there is a network performance based question, you can look at the instance type for an answer. So the answer could be like, take a bigger instance. So when a bigger instance would generally have a 10 Gbps performance or a 25 Gbps performance. So that's an important aspect that you need to look at when you're talking about network performance. So network performance will have some bearing on the, or I would say the other way, the instance type has a bearing on the network performance. So these sort of questions come up quite regularly in the exam. So when you're looking at the network performance, also look out for an answer which is not directly network performance based, but has something to do with the instance type. Again, when it comes to storage performance, you obviously would look at the disk and the speed of the disk, etc. Additionally to all that, there are instances which are EBS optimized. Basically, they are given a separate throughput for EBS, a separate, let's say, a bandwidth for EBS, so that they are able to access the disks without clashing with other traffic, and therefore you get much better performance. So there are certain limits. I think it's about 500 to 4000 is a limit. So you look at the EBS optimized instances as well. So when you're looking at an answer for a storage performance, once again, it may not just lie in the disk. It may lie in the fact whether the instance is EBS optimized or not. So if you have an EBS optimized instance, then that gives you much better performance. Or if they say, how do I increase the performance my storage, then you can also look at EBS optimization as one of the ways of improving your storage performance. You don't need to just look only at the disk. So this is something which you have to understand, that both networking and storage are also, their performance is also based on the instance type. So having a decent understanding of this is going to help you very much in your exam. And when you encounter such questions, you will look at the right answers, not just look at networking or storage, but also look at the instance types. Now, we will talk about cost optimization. And I found that in most of the exams, you definitely get a couple of questions on cost optimization. Here we are talking about cost optimization from an instance point of view. So let's first look at how the pricing works. The pricing works in on-demand instance will have a per second cost associated with it. So if you take an on-demand instance, you pay for the time when you start till the time that you stop. Start, stop, start, stop. So that is how they will bill you. So the number of seconds that you have consumed will be taken into account and you will be billed. You have reserved instances. Now, reserved instances are monthly billing instances. Basically, you have to pay a monthly fee irrespective of the fact whether you use the instance or not. You could have had the instance shut down for 20 days or in a month, but it doesn't matter, you have to pay the same monthly fee. As you know, the advantage of the reserved instance is they are deeply discounted. So depending on whether you take a 1-year term or 3-year term, you can get an excellent discount on them. So you have a discounted price there. Then there are spot instances. The spot instances do not have a clear fixed cost associated with them. they fluctuate based on the spot price. So per hour cost could vary, but this can be very cost effective. You can get instances at a fraction of their cost when it happens. So if you can get a spot instance, you may get it at a very cheap rate. Now added to it, what I've not shown here, but available to you is also a dedicated instance, which is a single tenanted instance, where there is a certain fee that you have to pay for using dedicated instance per region. So let's have a rule of the thumb and look at what sort of answers you need to give to different questions. Here is the basic rule of thumb as far as cost optimization goes. Suppose the question asks or question indicates somewhere that you need 3 servers running, web servers running all the while, then it means that you are using it 24/7 all the time. Then it's better to go for a reserved instance for that particular case. Same way, if you have something like a database, which you will definitely run as a part of your application 24/7, then it is better to go for a reserved instance because that's the cheapest you will get and you are using 24/7. Why not go for a spot instance? The answer is spot instances could be even cheaper than reserved instance, but spot instance property, as you would know, is that they can be taken away at any point in time. That is, your machine can be shut down any point in time by Amazon. So they are not a right fit for something which is required 24/7 or for something that should not stop. So if you want to auto scale your web instances, for example, you would not want to use spot instances. Why? Because web instances are interfacing with the customer, and without much of a warning, if an instance goes down, the transaction with the customer would be lost. You don't want that to happen. You don't want the customer suddenly to see a blank screen or an error screen. Therefore, for such things where you cannot afford to shut down, you don't go for spot instances. So if somebody says, I want to scale up the web instance, let's say the question is like, I want to, at any point in time, have 4 web instances running. And on demand, whenever there is a load, I want to add another 2 or 3 more web instances. How would you select what type of instance you want to buy, what purchase you would do? The answer would be that if you, at any point in time, you want 4 instances, those 4 instances have to be reserved instances. Now, because these are web instances, you don't want to buy spot instances for the extra 3. You don't want to buy reserved instances because they only come up when there is a need. They are not there 24/7. So the only option you are left with is to buy on-demand instances. At the same time, if the same question was asked to you that you need 4 systems in the backend which are doing some backend processing, and whenever needed, you may want to add more systems to continue the backend processing. In those type of cases where you do certain backend processing, where no user activity is directly involved, let's say you're doing some video transcoding and you suddenly want to add some more power to your infrastructure, in those cases, you can put up spot instances. Because even if they go down, it's fine because the other instances are taking care of the transcoding process. In that case, you get a much cheaper price and you are okay with the instances being stopped at any point in time because you have designed your application such a way that others will take care of it. So as I said, if it is an application where you do not want a system to stop suddenly without your control, those cases don't use a spot instance. But in a backend processing type of cases where you can offer a sudden stoppage, then go for spot instances. So that's how you will mix and match this. Again, as I said, rule of thumb, 24/7 reserved instance. You can offer to stop an instance at any point in time, and that instance only needed once in a while or whenever you need to boost up capacity. Then go for spot instance because you get at a much cheaper price. But if you cannot offer to stop an instance abruptly, then go for on-demand instance. Of course, if the need is for a single tenancy, then obviously you have to go for a dedicated instance. Dedicated instance could be used because of can be used in compliance side. The dedicated instance can also be used for getting better performance. So whether it's for compliance or better performance, whenever you need a single tenancy, you can go for a dedicated instance. And dedicated host also for compliance reasons. And sometimes when you have software which are bound to CPU and you need to know which CPU you are using, then you can go for a dedicated host. So this is a rule. And this, as I said, such a question generally appears. So give this decent thought when you see the question and look at all the aspects that I had mentioned here. A small point here. One is about scale up. If you want to scale up your instance, that is, you want to change your instance type, it's possible to do that. But the condition is that you need to shut down your instance, and only when the instance is shut down during that time would a scale up be possible. The other option is about accidental termination. Now, in accidental termination case, you don't want somebody to terminate the system. You can turn on the termination protection. There's a termination protection option available. So you can go turn it on. If that is on, then when you try to terminate, it will not terminate, but it will say, please go and switch off this option. Only then I will terminate. So you have to come back, switch off the option. So if someone, let us say you have another administrator who's trying to shut down, who's trying to terminate the system, sees this, then he would realize or she would realize that someone has actually protected it, and therefore will be cautious enough not to immediately terminate, maybe to discuss with the relevant people before doing termination. It's that's one reason why we could have a accidental we could have the termination protection turned on. Similarly, there is a delete on termination flag which is available on EBS volumes. By default, the root volume has this turned on. So whenever you start an instance, if you were to see on the storage screen when you are going through the step-by-step process of launching an instance, you will see in the storage screen that for an EBS volume there is a delete on termination flag, and that is ticked. So when that is ticked, what it means is whenever you terminate your instance, the root volume will get terminated. That is also deleted automatically. So you don't want that root volume to be deleted, then you can remove that flag. So for any other disk also, the delete on termination flag for other disks is always switched off. So when you terminate an instance, by default, the root volume gets terminated. The root volume gets erased or destroyed. The other disks that you have attached to the instance will remain till you delete them. That's the default setting. So if you don't want the root volume to be erased or terminated when the instance is terminated, you have to untick this flag. And then in that case, when the instance gets terminated, the root volume still remains and you can use it later for whatever purpose that you want. The other important aspect is about the instance metadata and the user data. A metadata is the data about the instance. Once you log into an instance, for example, if you log into your Linux instance, whatever you can find out from the inside the Linux instance is about the Linux operating system. That is, you can find out things when you say, I want to know which is the IP address I'm using. You would only get a local IP address there, that 172.16 or 172.31, one of that you will get. You will not get the public IP from inside the instance. You want to know what is the AMI ID of the instance. You would not know about that. You would not want to know the DNS name of the instance. From inside the Linux, you would not know directly. So you want to get the metadata about the instance, then you have to go to this particular URL, which is 169.254.169.254, and under that there is a latest and metadata directory. You can, if you are in Linux, you can use a curl or a wget command to get data from there, and inside that there are multiple directories, and each directory would tell you about different things. Some can tell you about AMI, some can tell you about the security group, some can tell you about the network aspects of it, and so on. So the instance metadata can be got from this particular IP address, 169.254.169.254. Then we have this concept of user data. So when you are launching an instance, in one of the screens, I think the config details screens, you can actually go and supply a script of your own. You can write a script and supply it. Let us say, as trivial as when the system starts up, I need a particular directory in a particular place. So I would say in my home directory, I need a directory called Cloud Siksha. Then I can write a small make directory command as a shell script and load it as user data. And when the system boots up, after the system boots up, that will create the directory that I want. The other thing also is that I can put much more than just this trivial thing. Like I can, as soon as system starts up, I want to boot, I want to download Apache. So I can do an yum install httpd or apt-get, depending on the Linux that you're using. And you can turn on the surveys, you can turn on check config and everything else using the user data. So user data can be passed, and the maximum size of the user data that you can pass is 16 KB. That is given when the instance is launched. As the instance is launched, user data is supplied, and after while the instance gets launched, right, the user data, whatever scripts you have, will also get executed. Another important concept, and this question generally turns up many a times inside, many a times in the AWS certification exam, is about placement groups. This is basically something which you require when you have applications which are cluster based, and these cluster, all the machines in a cluster are talking to each other. So let's say you have an application which is running on 4 machines, and all the machines are communicating to with each other, and they require high speed of communication, and a lot of communication happening, let's say. Then you can create what is called as a placement group initially and launch these machines in the placement group. What happens is that these are all launched in the same availability zone, and as you would know, that availability zone, the same availability zone, indicates that they are all in the same data center cluster within a region. Amazon also probably tries to launch these instances on systems which are physically close to each other as well, so that they can take advantage of the high-speed network within the Amazon infrastructure. So a placement group is in one availability zone. Of course, it cannot stretch into different availability zones for obvious reasons, because we are talking about high-speed, low latency network within all these systems. So they are all in a particular, any availability zone. You launch placement, once you define a placement group and launch instances, all these instances will be put close to each other. At least that's what Amazon would try to do, right? Now, if you want to take advantage of this, only certain instances type, that is those which have the 10 Gbps networking, are used there to in a placement group. The best practices that Amazon tells you is that if you want a good network speed amongst all of them, then it's better for you to launch all the instances in one shot. So launch 4 instances at the same time into the placement group and use homogeneous instances. That means if you're using a particular instance type, let all the 4 be the same instance type. And all the 4, of course, we expect it to have about 10 Gbps networking in them. And it's also good if you can enable jumbo frames. This is a TCP/IP concept where the size of the frames can be increased so to ensure that is better speed. So you can enable the jumbo frames as well. Also remember that if you have not launched an instance into a placement group, you cannot move the instance into the placement group. So the only option for you would be to, terminate the instance and then start the instance. And when you're starting, say that it has to go into the placement group. Of course, if you need, you should take a snapshot. You should create a new AMI of the running instance and all that, and then put it here, depending on how you want it. But remember, you have to launch an instance in a placement group. If you don't launch it in a placement group, it is not possible to move that instance later into the placement group. So whenever you see a question which is talking about clusters, which is talking about high speed between clusters, look for an answer which has placement group in that. That's very important. And I've seen this coming up in the exams quite often. So have a clear look at what is a placement group. There also, this I will also cover when I do this webinar for the CloudWatch part. But here, a brief thing here. One is, of course, when monitoring an instance, the hypervisor level metrics are the ones that are collected. So in that, you would get CPU usage, percentage usage, but you will not get memory usage, or you will not get disk usage. Those metrics are not got. That is important for you to understand. Disk read, disk writes, and all are given to you, but not disk percentage usage of disk. Okay, disk read, disk write, how many bytes read, bytes written, those sort of metrics come out, but not how much of the disk is currently occupied, right? Is it 30% occupied, 50% occupied? That metrics you would not get. The other important thing is about status check. And in the status check, you get 2 types of status check. One is called as a system status check, and the other is called as an instance status check. System status check refers to the health of the underlying hardware. So your VM or your instance is running on a particular hardware. The health of that hardware is what the system status check is looking at. Instance status check is the health of the instance that you're running. So a question can appear that there is some problem in accessing your instance, or you see that instance is not performing very well in the network and all that, and you go ahead and see the status check and you find that system status check is having a problem. What would you do? Now, if such a question occurs, then the answer is simple, that you will stop and start. Generally, when you stop and start, your instance will be placed on a different hardware. So if one hardware you find that system status check showing an error, or you find that your instance has slowed down considerably, though your application remains the same, your load remains the same, but your instance seems to be performing slowly than what it used to earlier, then also at that point in time also there's a possibility that your instance will improve its performance if you shut down and restart. Because on the same physical machine, if there are different instances running, the other instances may be contending for the same resources, and they may be doing too much of IO bound work or network bound work, and that may be impacting your instance. So if you shut down and restart, you may be placed on a different instance where you'll get back your original speed. It's possible. So these are some things. So to troubleshoot or to come out from problems or to overcome performance problems, sometimes you can just stop and start. Of course, it depends on the instance. Like if you are on a web server or something, it's not that easy to stop and start until unless you are behind a load balancer. And of course, if you have a database instance which has database running on it, you wouldn't want to stop and start until you have synchronous replica available to you to do that. So those are different. Those are of course different thing. But on a broad view is that you can start and stop and start, and because stop and start, some of the problems would go away, like the problem of connectivity, the problem of efficiency, performance, etc., would go away. Now I will shift now to EBS, and we will talk about EBS and instance store. As you know, EBS stands for Elastic Block Store, and it's a persistent storage. What it means is the system goes down, system is rebooted, no data is lost. The disk get attached again, and the data is very much available to you. Whereas the instance store is ephemeral storage. There, the storage comes from within the server on which your instance resides, and when you shut down your instance and restart again, the data is lost. Whatever data you had written to these instance store disks is lost. That's why it is called as an ephemeral storage. Similarly, if the system crashes, your data is lost. Whereas in EBS case, the system crashes or you shut down the system and restart, nothing happens. But one very important thing you have to remember is, if you reboot a system, then in the instance store case also, you will not lose data. The data would still be available. It's only when you stop the system or the system crashes that the data is lost. Therefore, whenever instance store is available to you in an instance type, you use that only for temporary storage. You can use that to do a lot of IO, fast IO. So if you see the storage optimized instance, they give you a lot of SSD based instance store. You can do a lot of fast, quick IOs there, because instance store is part of the server on which your instance resides. Therefore, that will be much faster. But what would happen in those cases is, you store the temporary data, work on that data, transform the data, and then when you store it back, you store it either in S3 or in EBS, so that even if the system goes down, you still have the data with you. The other question that comes up again is about performance here once more. This is about the disk performance. Now, there are multiple types of disks available to be attached to an instance, of which the fastest is the provisioned IOPS, and then comes the general purpose SSD. These are all focused on IOPS. IOPS is input-output operations per second. So if you have a lot of read-writes happening, you need a lot of input-output, then these type of disks are what you are looking at. Whereas there's other type of disks that you can use. They are throughput based. That is, they give you better throughput, the better bandwidth. So if you look at IOPS, they are talking about input-output operations per second. Whereas if you're looking at the throughput optimized, you will talk about MB per second. How much MB per second you can transfer to that. So there are throughput optimized HDD. There's a standard HDD. There is a cold HDD. So throughput optimized HDD gives you a lot higher speed than the others. Currently, the IOPS limit has been raised for the provisioned IOPS and general purpose SSDs to 32,000. And generally, you have to understand that there is a certain ratio that is given. So it is like you cannot have any IOPS that you want. Suppose you want 32,000 IOPS, you can't have it on a 1 GB disk. You will find that you need at least a 16 terabyte disk or 10 terabyte disks for you to get that. Earlier, that ratio used to be 30, but with the IOPS limit going to 32,000, we need to check up in the manual as to what that ratio is. Because, for example, in a general purpose SSD, the general purpose SSD gives around 3 IOPS per, I think 3 IOPS per GB. So if you have 1 GB, you get 3 IOPS. So if you get to the number of IOPS will then go as per. So if you have 500 GB, you get so the same thing, 3 into the 500, 1,500 IOPS, something like that. So this is important for you to understand. So how much is the IOPS per GB that can be got in provisioned IOPS? How much you can get in general purpose, etc. Another thing which comes up as a part of disk performance is you have a limit to the IOPS that you can get in provisioned IOPS. So what happens if I need more performance? And there's also a limitation of 16 terabytes as of now on the disk size for provisioned IOPS and other disks as well. And this keeps changing. So by the time you read, it could even have changed. It keeps changing, but don't worry. But the idea is, what if you want more storage than what is given to you? What if you want more performance than what is given by a single disk? Then you can go on to do what is known as a RAID 0. So you can do a RAID 0 configuration on the disks. So take 4 disks, make a RAID 0, so you will get much higher IOPS than what you can get for a single disk. And similarly, RAID 0 will give you much larger disk space than what a single disk can give. Here you don't need to do RAID 5 or RAID 10 and all, because RAID 10 or RAID 5 are all towards protection, right? You are ensuring that your data is not lost. But in the case of Amazon, they anyway ensure that the EBS actually is replicated, so your data will not be lost. It's only a question of getting better performance. So going for a RAID 0, which is striping, will improve your performance. So look at that. So whenever they are talking about performance and all, look at if they have a RAID 0 option. Sometimes there's no RAID 0 option, then look for RAID 10 option. That's the next best thing. But generally, RAID 0 should be the best option available for you in the case of EBS in AWS. Okay. Now, in a normal storage array, you would not ever go for a RAID 0. You would probably go for 10 or RAID 5, RAID 6 type of thing. Well, that's a different thing. But here, look for a RAID 0 so that you understand how. So you ensure that you can get lot more IOPS and you can get larger disk space. So the performance versus cost here, again, you will have to take a thumb rule on which would you buy for what. So what type of storage you select would not necessarily be just that I want the best storage, right? It depends obviously on the application. So if your application is doing a lot of read writes, these are like large databases with a lot of people accessing the database, a lot of requests coming to the database. Those type of cases is where you would go for provisioned IOPS, because IOPS on SSDs, they are much better, and provisioned IOPS gives you a guaranteed IOPS, and it's very good for random read and random writes. So small read, small writes, it's much better. If you want higher throughput in terms like higher throughput, then you can also look at the HDD option, where the HDD is throughput optimized. Suppose you want to do video streaming type of thing, then you can look at that. And if you are storing some data, you want it as primary storage. You don't want that in S3, but you want it in your disks as of now. But you know very well that those folders, those files may not be stored much. I mean, not stored, I'm saying, may not be accessed much. Those cases, you can go for cold HDD. And HDD, normal HDD, you can go for when you have a small database, not too many read writes happening. And in all other general purpose cases, you can look at the general purpose SSD. So you will, whenever they ask you about cost from the perspective of disks, look at what is the application. So look at the application, accordingly take it. So don't think that every time I want to take a cold HDD because it's the cheapest, but it will have an impact on the performance. Or don't look at every time I want IOPS, provisioned IOPS, because that is very costly. And if you're not accessing your data very often, then going for provisioned IOPS may not be the right solution. So look at what they are asking you in the question as to what is the primary concern, what's the application which is there, and accordingly map the disk that would suit that application, and will also ensure that the performance and costs are balanced. That's what you need to do when you're looking at EBS disks. Finally, we'll take a snapshot. Like the AMI, snapshots also belong to the region in which you have the volume. So if you have volume and take a snapshot of the volume, whichever region the volume is, snapshot will belong to that region. AMI is also nothing but a snapshot plus certain things more, like registering with the AMI with Amazon and all that. So the same properties apply here. That is, the snapshot can be copied from one region to the another region, right? And if you have encrypted volumes, you take a snapshot, you get encrypted snapshot. So you cannot take a normal unencrypted volume and say the snapshot has to be encrypted. That won't happen. So these snapshots can be copied to another region as well. And a snapshot happen asynchronously. That is, when you take a snapshot, it starts the snapshot, but allows you to keep using the volume. That is, the snapshot happens in the background as you are. So it doesn't mean that you have to shut down your system and then take the snapshot. Only the shutdown happens only when you do the AMI to get a consistent image. So they generally reboot the system, take the volume snapshot before booting the system again. But in normal snapshots, you don't need to shut down the system, or your volume is available for you to continue using. Similarly, when you make a volume from snapshot, it doesn't wait for all data from snapshot to be copied into the volume. So the volume comes up earlier, and in a very lazy manner, they copy all the data. So that's another thing, so that the disk gets available to you much before the complete copy happens. That also we have to take into account. So those questions may appear in that area as to when the snapshot is available, when the disk is available, and so on. So keep this in mind. And snapshot is incremental. So whatever you've taken last time, if you take another snapshot now, say 1 hour earlier you took a snapshot now, so whatever was the difference in the blocks between last time and now is the only one which is copied, not the whole disk. So that is incremental. The way you can move a disk from one availability zone to another using the snapshot. As you know, an instance when launched in availability zone will only come up in the availability zone. Volume which is created in availability zone will remain in the same availability zone. You cannot move it to another availability zone. So only way you can make a copy of the volume is to take a snapshot, and from the snapshot build a volume. But when you're building the volume, choose another availability zone and build the volume in that availability zone. So that has an effect of transferring your disk from one availability zone to the other. Similarly, if you want to, when you make a volume out of a snapshot, you can increase the volume of the, increase the size of the volume, but you cannot decrease the size of the volume. So and remember, if your disk is 500 GB, the snapshot will be 500 GB. It doesn't matter how much you have written on the disk, the snapshot size will be 500 GB. And when it makes another volume, it will ask for 500 GB. You cannot reduce that. The minimum size is 500 GB. But if you want to make it 1 terabyte, you can make it 1 terabyte. So this is about snapshots. So with that, we sort of end the presentation part. Just as I would say that, just a quick thing about what we are doing at Cloud Shiksha. So as you would know, we are conducting multiple courses, AWS developer courses, DevOps courses, certification courses, and we are there on Udemy. We are there. We have our own academy wherein